Greetings once again and welcome to my new calculus channel. My name is John Gabriel. So in a previous video, this one here, I showed you how to solve basic math problems and to understand the methods. One of the problems that we were dealing with showed you how to use an LCM to solve the problem. But of course it didn't explain anything about an LCM, what it means, how it's used. So what really is an LCM? Well, in very simple terms, an LCM, if we look at it geometrically, is the same as taking two unequal lines, any two unequal lines, okay, and then using a method to try and make them equal. Of course, they must be, even though they're unequal, they must be in terms of the same magnitude or unit. Okay, so in other words, you could have a line that's maybe 6 and another one that's maybe 5 or whatever, or just as long as they have a different line length. So let's go through the process. The two trains here arrive every 18 minutes and 27 minutes respectively. Okay, so what's going to happen here is this. So we've got now train A is the blue line and train B is the red line, and so what we're going to do is we're going to say, let's take train B is actually the train B is the blue line and train A is the red line, and let's just put the association like that and like that. Okay, so now what we have to do is we start off with the longer line, which is the blue line, right? And then what we do geometrically is we take the red line and we start off by aligning it with the blue line and then continuing to extend itself until it surpasses the blue line. So we only need to do that twice. So we've done that twice now, right? Just like that. So now it surpasses the blue line. The minute it does that, we stop and we grab the blue line. Okay, and then we add the blue line to itself. So they're not equal yet. The stopping condition happens when the two lines are equal. And it turns out that after we add three times the length of the red line, two times the length of the red line to itself, and one times the length of the blue line to itself, that we have equality. And if we measure the number of units in each, well, then we know that it will be 54. So the lowest common multiple here is 54. Now, this is also a good method to find the product of two numbers if they have no common factors. Okay, but now, if in this example, where we have 18 and 27. Now, what is 18? What is the product of 18 and 27? The product of 18 and 27 happens to be 486. Okay, so we have that the product is 486, which is not the same as the LCM, but that's not a problem because the LCM, which is 54, is a factor of the product, and any other LCM we find, well, not any other LCM, any other greater equality that we might find by continuing to add these lines again will always be a factor of this number, okay, up till a certain point where it will reach 486 and even surpass it. Okay, so in which case it will become a multiple. So LCM basically means the least common multiple, and it means taking two numbers, which in this case were 18 and 27, and saying, okay, well, 27 is greater than 18, so let's add 18 to itself. That will give us 36, but now 36 is greater than 27. So we still need to add another 27. But now, in this case here, we've got 54, right? Which means 54 is greater than 36, which means we need to add another 18. But if we add 18 to 36, we then have 54. In other words, 54 is the LCM. Okay? So that's a way to understand the common multiple using geometry. And it's very important because later on in algebra, as you see, with these kinds of problems, and there is a link to this video. I'm not going to continue very far now because you can read the link. I'll show you the methods and the discussion that takes place with ChatGPT. If you're not already a subscriber to my channel, please become a subscriber. Click like, follow me on Academia.edu, become a member only so that you can engage in my special series on the works of Archimedes. And more on that will be forthcoming. It's just that it takes time to produce good content. So, till next time, I'm John Gabriel. Goodbye.